Okay, Assalamualaikum dan welcome back to our class on instrumentation and measurement. So now we're going to talk about our first type of transducer, which is called resistive position transducer, also known as linear potentiometer. And I'll let you know why it's called potentiometer. Okay, so let's go ahead. All right, so what is this equipment? Is resistive position or displacement transducer. So the purpose of this transducer is to measure distance or displacement or position anyway. Okay, not a very long position, and maybe short position, maybe a few centimeters, a few millimeters, inches and stuff. Okay, so the operation principle is that, okay, if you look at this figure on the right here, okay, I just show this is the actual example of an actual transducer. So as let's say, for example, if something is attached to the end of this shaft here, and there's a shaft that can move back and forth, and so the position is measured depending on whether the shaft is going in and out from the container here. Okay, if you look inside the circuit, the transducer, you will have, okay, if you look on the figure over here, you will have some what we call a slider, a shaft, which is connected to some position you want to measure, and you have a wiper here, a movable sliding contact, and you have like some sort of a wire, a long potentiometer wire, something to look like a potentiometer. I hope you guys still remember what is potentiometer. Okay, so basically it's a long wire wrapped around a case, and then the total resistance is distributed evenly across the potentiometer. All right, so if you look at the operation principle here, basically this transducer use a resistive element or resistive wire if a sliding contact linked to the object being measured. Okay, so the contact is connected to the shaft here, and whenever the shaft moves in and out, changes position, then the wiper contact will also slide back and forth between A and B. Okay, so the measured quantity of position position of the object cause a resistance change between W and B. Okay, but W is the wiper. Okay, it's the movable part can move between up and down here between position A and B. So okay, so we will take a look at how to measure the voltage and current after this. So it is a passive and a linear electrical transducer. So it's required an external voltage of VT. So you need a voltage, DC voltage here, okay, in order to measure the voltage and the of this transducer. So the input here as a transducer, it must be something like a non-electrical, which is a position. The wiper contact, see the position of W here, and the output here is the output voltage V0, which is the voltage between point W and B. Okay, so the output voltage is here. All right, so let's take a look at further detail. If you take a look at this diagram down here, okay, so you have A is basically a position for full output slider position, B is basically the position for zero output, and W is a wiper or movable slider contact between A and B. So basically it depends on where W is. It will split the resistance R1 and R2 between A and B into two, R1 and R2, similar like a potentiometer. Okay, so the shaft, as I said before, the shaft and wiper can be moved from left to right, causes a change in the circuit resistance. Okay, so if the resistance of the transducer is distributed uniformly along the length, the resistance will be linear, similar to a potentiometer. So the resistance along the circuit, the total resistance is R1 plus R2. Okay, so if depending on where W is, it will split the resistor into two. It's like a voltage divider. Okay, so therefore, using a voltage divider rule, the output voltage of the circuit can be calculated just simply by using this formula. This is, if you look at this circuit here, okay, so V0 is basically divided by VT is R2 divided by R1 plus R2. Therefore, V0 is R2 divided by R1 plus R2 multiplied by the source voltage here. Okay, so we take a look at one simple example after this. Okay, so where V0 is the output voltage, VT is the supply voltage, R1 R2 is the resistance divided due to the movement of the wiper. Okay, let's take a look at one simple example before we move on to the next type of transducer. So in this case, a resistive position transducer or linear potentiometer for total shaft stroke of 3 inches. So basically this transducer measure from 0 to 3 inches. Okay, because it's a very, very small transducer to measure very small movement, maybe a movement of equipment that you want to measure, a very small equipment. Okay, is applied to the circuit. So the total resistance of the potentiometer is 5 kilo ohm. Okay, so when you say total resistance is R1 plus R2. Okay, the applied voltage VT is 5 volt. Okay, and when the wiper is 0.9 inches from B, what is the value of the output voltage? Okay, so how to solve this problem? So I already put the solution here. So if you want to find the resistance, because R1 as the resistance between A and B are evenly distributed. So let's say, for example, the total the potentiometer is 5 kilo ohm. So if you are in the middle, which is basically maybe 3 inches is 1.5 inches, then you will have half the resistance. Okay, so if now you are in a 0.9, so just divide by 3 the total length of the potentiometer multiplied by the total resistance, and you have approximately the value of R2. R2 is basically between B and W. Okay. All right, so and then just use the formula that we have shown before. Okay, you can calculate the voltage, output voltage is just R2, they calculated here, plus the total divided by the total resistance multiplied by the voltage, and you finally have V0 is approximately 1.5 volt. So basically, what happens is that this transducer will sense a voltage of 1.5 volt, and then it will be translated into the display saying it is around 0.9 inches. Okay, so it has been scaled that way. All right. So this is how the linear potentiometer works, or resistive position potentiometer transducer work. Okay, so I have another video on this, YouTube video from external reference, so you can go and check it out. So I'll see you again in our next transducer video. Stay tuned. Okay, thank you very much. I see you again. Bye now. Assalamu alaikum.